Okay, here's our video, Precalculus, the second unit, first video, talking about trig values on the unit circle. And the unit circle is exactly what it sounds like, right? Unit. Unit means one in math. So whatever the unit is, right? If you don't know what the measurement is, you just say unit. 1 unit, 1 mile, 1 centimeter, 1 kilometer, whatever the case may be. So a unit circle means that all the radii on the circle is 1 unit. And then we'll talk about the trig values that you should be familiar with. You probably have seen them in Algebra 2. Well, you should have seen them in Algebra 2, but just to review them, let's make sure we have our pen. The 6 trig ratios. So there's sine, and I'm just using the abbreviations, cosine, there's tangent, and then there's the reciprocals, which we'll talk about, cosecant, secant, and cotangent. So with sine, we know it was the opposite over the hypotenuse. The reciprocal will be for cosecant, the hypotenuse over the opposite. For cosine, it was the adjacent over the hypotenuse. And the reciprocal for secant will be hypotenuse over adjacent. For tan, it was the tangent, opposite over adjacent. And what do you think the reciprocal would be for cotangent? Exactly, adjacent over opposite. So for this video, we'll just talk about sine right now, and we'll talk about finding degrees to radians, so we also should know that. So mostly in your math career in high school and going into college, you'll be using more radians. So degree to radian is essential. You should know how to convert that. We'll do that in the videos. Let's do one already. Let's say you had 30 degrees, right? So how can I take 30 degrees and make it to radians? So we'll just take 30 degrees, put it over 1, and the formula is just times it by pi over 180. So just get used to that formula. And of course, 30 goes into 180 6 times, so the answer will be pi over 6 radians. And I'll go over that in this video today when we look at the unit circle. So let's get a circle. All right, let's now make our unit circle. There's our circle. What should we use? Green. And I'll attempt to draw a straight line. Get it down there, close enough. And we'll pretend that's in the middle. So again, I made all these radii, and each radii will be 1. Each radii will be 1 on the unit circle. It's important to know special triangles. Certain special triangles are the 30, 60, 90, which we'll talk about in this video. And there's also the 45, 45, 90 triangle. So if I made a triangle, have my box at 90 degrees, and then we had our degrees over here, we'll just use 30 and 60. There's our special triangle. There's a certain ratio of the lengths of those special triangles. Do you remember what they are? Well, one side, the opposite of 30 degrees will be x. The hypotenuse will be 2x. And this side here that's opposite 60 degrees will be x over pi over 3. X pi over 3. So for example, let's say you had a triangle and you had the hypotenuse of 1. So if the hypotenuse is 1, that means this side right here has to be half, because remember, the hypotenuse is double in the special triangle, 30, 60, 90. And then what would this one be? What would, right there where the arrow is pointing, what would that be? Well, it'll be x pi over 3. Square root of 3, that is. Which comes out to just 1/2 pi over 3, which is pi over 3 over 2. Just review that, and we'll go over the unit triangle again. So again, you have to remember these special triangles, the 30, 60, 90, and the ratios, and the 45, 45, 90. So let's say we have a unit circle, and we've created a triangle, and let's say that's at 60 degrees. So what would be the radians on that? Do you remember how we got the formula? So get the radians. So again, remember, like we did on the video, you just take the degree, 60, and times it by pi over 180, right? And you'd get 180 over 3. Sorry, you would get pi over 3. Pi over 3. So 60 degrees is pi over 3 radians. Now, let's say we wanted to know, because we know at this point here, I'll make a point here, we'll call it point A. We know that point A, the x is at 1, because it's the length of 1. It's the unit circle. And the y will be at 0. And if we call this point B, we know point B, we don't know what x is or y as of yet. We know this point over here, if we call it C, we know C is on the x at 0 and the y is at 1. So look at that for a minute. It's getting a little blurry here with all this writing. Now let's say we want to find the point, the coordinates of B. So we'll just draw a straight line down, and then we created a 90-degree angle there. So if this was 60 degrees, that means this is 60. Or pi over 3, that means this is 30. So use the special triangles now and see if you can find what the lengths are. Well, we already know that this length is 1. So we're trying to find this length and that length. Now again, the 1 is from the origin to A, so don't look at it as 1. So what do you think? Use what I did on the left over here. Over here. Be careful on the degrees though. See what you get. And we should use another color. It's getting... So again, the opposite of the 60 degrees, this is 60 degrees here, or pi over 3. The opposite is over here. So we know that length has to be, because remember, if we looked at the ratios, it should be x over x square root of 3. And over here, this should be just x, that line of x. So if that's 1, we know that from this point to this point should be half. So if let's just call this Q. So point Q, so it doesn't get too blurry, we know that the x part is half and the y is at 0. We do know that if the x is at half, we know that here at point B, we know the x is half. Now, and the length is going to be x square root of 3. So we know x is half, and then we have square root of 3, which would be the square root of 3 over 2. So y would be the square root of 3 over 2. That's how we got it. Now, let's clear this out. Go back if you need to. Clear it all out. Make a fresh page. All right. And we'll make another. Just do one more here. What if we had, now we'll do 30 degrees. 30 degrees. So that's 30. And of course, what's 30 degrees? We did that before. Do you remember? 30 in radians, right? It's pi over 6, right? So we have pi over 6 radians. Now we want to find the coordinates of that. Let's say the coordinates of A. So why don't you pause the tape, see if you can find the coordinates of A based on what we've done so far. All right, remember, I'm going to draw a dotted line, and we're going to create a 90-degree angle. And we know that from the origin to the center, to the edge of the circle is 1, it's a unit circle. We're trying to find, we'll say B and C. We'll try to find the length of C and B to find coordinates of point A. So how do we do it? So now, again, remember, we have a 30, 60, 90 special triangle. The 60 is over here. So opposite to 60 will be x over square root of 3. And the opposite of 30 would be half. So what is half of the hypotenuse? It's half, right? I gave you the answer right. It's just x. Remember, the hypotenuse would be 2x. So half of the hypotenuse is half, right? So we already know that this length right here is y. So we have for A, we have the y as half. And we've done this before, but now the x is half, and we have square root of 3, which would be the square root of 3 over 2. So that's x. From here, change the color a little, from this origin point to this point here, the x is this. So we know it's square root of 3 over 2. That's the coordinates of A. All right, so we'll go into more on the next video.